So hi everyone, we have the very difficult task to close this session, and maybe it's probably the last technical talk of the day, so we are the very last obstacle before your beer. So yes, we'll hopefully make it as lively as possible. It's really a great pleasure to be there today, to be able to speak about our several initiatives that we are conducting right now at the Federal Statistical Office in Switzerland, trying to champion differential privacy within the Swiss Federal Administration. So I'm here with my colleague Pauline, and we'll present you two initiatives that we have been working on over the past few months. So just a bit of a notice, everything that we're presenting today are innovation project, pilot projects, so nothing has been moved to production yet, because obviously you're well aware now that well, we need to convince a bunch of people, legal team, we need also the IT infrastructure to get on board. So this is an ongoing process, but at least we are constructing projects to just show that these things are possible, and we have really great opportunities to get better value from the data that is held within an administration. So just a bit of context, we are part of a data science competence center that has been created by the Swiss government about 2 years ago, and we have one mission which is about providing expertise in data science to the Swiss administration. So for that, we are conducting innovation projects, and while we are doing so, we need to ensure that actually we are following the rule of law. This is why we have developed a code of conduct, which is divided into 3 main pillars. One is about ethics, so just make sure that your all the data that we're using is representative. The second one is about transparency, so to ensure that everything is reproducible, that we are using open source software, that any algorithm that we are developing is explainable, and so on. And the third pillar, which is the one which is of high interest today, is privacy, and more precisely, data confidentiality. This is actually why we've been trying to experiment with differential privacy within the Swiss administration. So I'm going to present 2 projects. Well, I'm going to present one project. Pauline is going to present another one. The first one is about the poverty statistics in Switzerland. So just to give you a bit of context, there's a yearly survey called the SIG survey, which is harmonized at the European level. So every country in Europe actually achieved this project every year. And in Switzerland, it means that there is a phone questionnaire for about 17,000 people. So it's a rather small group, because Switzerland has about 8 million people. And so this has been very well designed by our methodological team, such that even if it's such a small sample size, we still can get robust estimates for what we call Grand Region in Switzerland. So it's those 4 regions that you see here on the right. Now, we just received recently a request from our government to actually produce this statistic at a much finer resolution. But the idea is that this phone questionnaire is already quite expensive, so is there a possibility that we can still provide this robust statistics, but not increasing, engaging more resources by increasing the sample size? So the idea has actually been to perform data imputations. So here, we want to leverage potentially auxiliary source of information that is available at the population level. So this is usually register data, so it's like location of residence, family status, is the kind of information that would be available for everyone who's be living in Switzerland. And so the idea of data imputation is quite simple. So you have a scary mathematical formula, forget about it, but the idea is that we're going to use 2 kinds of data. The one here first is the data that is coming directly from the survey, and the second kind of information is for whoever has not been member of the survey, is an estimation of the poverty status based on this auxiliary information Zi. But to do so, we need actually a function small f, this is the part in red, which links the auxiliary information to the poverty status. So this is something that is unknown in general, but the idea is simple, is just to use machine learning to learn this function from the data. So we've been conducting this project, just trying out multiple models. This has been performed by my colleague. Actually, I'm not directly involved in this part of the project, and they've been also doing an amazing job in quantifying the uncertainty of those models, because this is the most tricky part. Now, the idea is that now that we have this machine learning model running, we have an estimation of the poverty status of each individual in Switzerland.
So we are not only able to produce the statistics at a finer resolution level, at the cantonal level, which was requested by the government, but we could go even higher and higher in resolution. And actually, this project, we're not the first one to have done it. It's been done by the Austrian Office of Statistics, and they've been issuing maps at a very, very high resolution. But obviously, the higher in resolution you go, the higher the privacy risk is. And so this is why there's a huge challenge in releasing this kind of statistics. This is why we've been using differential privacy, or trying to use differential privacy. So you've been this schema if you have attended Sally's presentation, where actually we use the source data, which is the SIG data plus our auxiliary source information. We create a database with the poverty status for everyone in Switzerland, and then we use differential privacy just as a layer of protection when we release those statistics. Now, we're not the first one to attempt this kind of task in a production setting. Actually, we are all following the example of the US Census, and one of the key takeaway is that to be able to do this in a production environment, we need secure and robust end-to-end data pipelines. So this is why tools such as anti-granular could be extremely useful. But in terms of applying differential privacy, pure differential privacy, we've been partnering for about 1 year with the project OpenDP at Harvard University, and we've been developing new components within the package such that we can have end-to-end data pipelines. So this is an ongoing work. We've been trying to integrate. So OpenDP is a library that is developed in Rust, and so to be able to have data representation in Rust, we need some library which is called Polars, which is the equivalent of Pandas but for Rust. And so there's been a huge work that has been done by Mike, by Pauline, and Anna, trying to incorporate Polars into OpenDP such that we have end-to-end data pipeline, so we can take the raw data, ingest the data, process the data, and then release statistics all within the OpenDP library. Now, this is unfortunately not the end of the story, because now we have private statistics which are protected thanks to differential privacy, but differential privacy does not offer sufficient level of protection when it comes to georeference data. So it's been well explained by multiple speakers during the event. So for instance, when you have correlation within your data, so multiple households, multiple persons who share the same sensitive attribute but live at the same location, then differential privacy does not allow to protect for this kind of particular privacy risk. So we're also collaborating with Harvard University and with the OpenDP project to see if we can cope for this kind of problem of classical differential privacy and improve the current framework. So now I'm going to leave the floor to Pauline to present another project.
Yes, thanks, Raphaël. So I'm going to explain our platform to share sensitive data with researchers. So actually, the inspiration really comes from the UN Pet Lab hackathon of last year, where Oblivious developed a platform where people could do search queries on a sensitive data set and get the result with differential privacy. And they have been kind enough to share their code with us, so it was a great starting point for us, for this project. There are two main reasons to do this project. First of all, to increase the efficiency when sharing data with researchers. It will simplify procedures, and also is good for the reputation of the Federal Statistical Office, because we enable data analysis on sensitive data for the public. So that's the overall architecture. So on the right side, you have the researchers which want to have access to data, and the data is safe on the federal IT infrastructure on a secure server. We have a database which has the information of all the possible researchers and their budgets. And to do the queries, the researchers log into a virtual machine, which is also into the federal IT infrastructure, and they can do queries on the secure server in the same way as a hackathon and get the differentially private results. And we handle all the differential privacy logic, so we check if they have enough budget. After the query, we remove the budget, and so on. I will show a small demo. I don't know how I will do with the mic, actually, but there are two data sets. Two notebooks. One I will go over very quickly. It's to show the server side, and one is more the researcher side, so the most interesting parts. And it's a setup where we have the penguin data set. So we have Dr. Antarctica, which wants to know if the bill lengths of penguins differ between species. Yeah, thank you. So first of all, we just want to show that it's very simple to deploy it. There is no complex infrastructure. We just need to do Docker system up, and all this Docker compose up, and the system gets up. So there is a server, as explained in the slide, and the Mongo database, which is a database which handles the user management with the budget. Then there's two notebooks. So the first one, very quickly, it explains how to start the server. So that's just for having a nice output. Then that's just for communicating within the server. And we have a lot of functionalities that are prepared, but I'll just show the two that we need for the client side. So first, we need to set the metadata of the dataset in differential privacy. You need to set the bounds. And we chose to use the same format as Smart Noise SQL. So for the Penguin dataset, all the rows with the bounds and the type. And we add the metadata. So add metadata from this YAML file, and that's the metadata of the Penguin dataset. The second one that is important, so I just clean, for the other notebook, is to give to create a user and give them budgets. So the Dr. Antarctica on the Penguin dataset, and we give her a very big budget. It's just for the demonstration purposes. Of course, we don't give 40 epsilon, but to make sure everything works well. And that's done. So now we can go to the client side. So now we're in the setting with Dr. Antarctica, actually wanting to work with the server and getting information. So first of all, Dr. Antarctica would connect to the server, and so therefore we have a local library with the client, and she connects to the server. So she needs to give her name, the dataset, and later there will be probably a lot of more security. For now, it's as simple as this. So we can imagine she has never seen the data. So the first step would be for her to have a view of the metadata. So the very simple function for this is get dataset metadata, and it's the metadata we set in the server notebook. So for instance, now she has the information that there are 7 columns, 3 of which are string types and 4 are of float type. Yeah. Then now that she has an idea about the metadata, she wants to see the dummy dataset, and that's something that we do on the fly. So based on the metadata, when she wants to see a dummy dataset, we create a dummy dataset on the fly based on the metadata and return it to them for 200 rows and a seed of 0. So she can have an idea of the dataset. There's another thing. So now she wants to be sure that the query that she will do works on the dataset. And so she prepares a query, but she's afraid that it's not the query that she wants, and she will waste budget, which would be a shame. And so there is the option to test the query on a dummy dataset, and the same dummy dataset as the one she has on her notebook, but within the server with Smart Noise SQL. And therefore, there's just a dummy option, and she sets still the number of rows and the seed, and she's able to, forgot to run the query. She's able to get the average bit length based on the dummy data set on the server, running the exact same code as it would be with the real data set. And so she's quite sure it will work when she tries on the real data set to not waste the budget. She can also check on the same dummy data set that she has locally that the results are close enough, and so that's really doing what she wants. And it is the case, they are almost equal. Then the other option is for her to check her initial budget, so what we said before with 40. So the total spend, so for now it's 0. She didn't spend anything yet. She just worked with dummy dataset, which are public information. And she can see her remaining budget. It makes sense. It's the same as the initial budget because she didn't spend anything. The last step before doing the real query would be to estimate the cost. So in SmartNose SQL, which is the main one we have for now, when you do a query, the actual cost is more than what you ask. So we just check what it will be before so people can, Dr. Antarctica can adapt. So for instance, with 1 epsilon, it would be 3 epsilon that would be spent. So she can think it's a bit too much, let's do less. And with 0.2 epsilon, it would be 0.6. That's enough. Well, that's good enough. And so she can choose these parameters and query on the real data set. So here we set dummy equal false. So it would be, it's the exact same code, just changing the flag for the dummy data set, and it will query on the real sensitive data. And so she can know that the average bit length is 43.18 millimeter. And then, of course, other functions to get the remaining budget and the total spent budget. Then I can go very quickly. So there are options. You can go a bit, of course, do far more analytics. So she could compute the confidence interval of the data set following the same procedure. So writing the query, checking on the dummy data set that everything works, and then getting the inserts from the real data set. So if I run everything, with just a query to get the number of penguins and the standard deviation, we had the average before, we were able to compute the confidence interval, and it also goes until hypothesis testing. So I will not go through all the cells, but we just do a group by species. So we check the remaining budget, we check on the dummy data set everything is working, and we do the real query. And then, of course, in differential privacy, you can do all the post-processing you want without spending more budget. And so when she has the average, standard deviation, and count, she can do any processing, so the t-tests and the confidence interval and so on. So that's what we have here. Confidence interval of every species. So thank you, Raphaël. So that's it for the demo. And last slide of the day. For the future, we plan to continue with SmartNose SQL because it was the easiest to start with and it enabled us to really see the architecture. Next step would be the integration with OpenDP, especially with polars. Then we plan to make really the project open to contribution, so it's an open source project. It's already available on GitLab, and we really have a special focus on decoupling components to enable then other researchers to add access to other databases or other differential privacy library very easily, and that it's seamless. And we want to integrate it as a service in the Data Lab platform such that other national offices can use it. So yeah, that's it for the server.
Thanks. I'm sorry if, because I'm not an expert in differential privacy, but one thing that I didn't understand is why is the curving of the confidence interval, why do you need to spend, to verify and to spend basically your budget for that? Because I wouldn't assume that this is, I mean, but yeah.
So it's really just an example with the penguin data set,
Okay.
but we spend a budget to get the information about the count, the average and the standard deviation. So this gives information about hypothetical sensitive data, and then the rest is just post-processing and no budget is spent at all.
Okay. Because there is a risk basically that sensitive information could be revealed even through the, okay.
Yeah.
Okay.
Sorry, just to confirm on that, I'm going to pass the mic back in a second, but how much noise is applied is free, right? You're talking about the standard deviation of the data itself. You're not talking about the standard deviation of the distribution of the noise that was applied during the DP step. That's free, because that should that shouldn't be based on sensitive data. So that should be kind of public information.
So that's the standard deviation of the buildings of the penguins inside. That's,
Yeah. So the standard, the noise, like the size of the noise, would be free. Yeah.
We are mixing two worlds here. We're mixing the world of statistics with the world of differential privacy. And so the standard deviation that is mentioned is the one that we use from the data set to compute hypothesis testing. And this is a query because I need to compute the sum of the square minus the difference. And so because I need to compute this query, then I need to spend some budget. Thanks to Jack.
So I'm not going to ask a technical question about differential privacy. Which is probably good news for this time of day. Raphaël, I was really interested in, I think the narrative that I understood, and maybe correct me if I'm wrong, is that effectively the bottleneck in this project is now, like the poverty mapping, is now getting differential privacy to a point where you feel it is properly safe because of the geographic constraints. So you've got DP to a point where it's pretty good, but not quite there yet. And I guess, I wonder, you started this with a stakeholder who really wanted this data, and maybe there's a privacy utility trade-off here that we haven't really talked about that's just being time-bound and needing to deliver something at some point. And I wonder how much pressure you're under just to go, you know what, we've got an SDC method that's almost surely better than anything we could have come up with without DP, and now we should just push on and publish these statistics.
So I think with the time constraint, we're going to disclose cantonal level with classical disclosure control. Now, for the future, it was a great way to use this as a way to showcase how it works and to be able to give an example within the office, a tangible example. But for the publication of those statistics on the short term, I still don't know if we're going to use differential privacy. I hope so. But indeed, well, they might stick to classical disclosure control for now, especially if they keep it on a very high aggregate level. It's just, if they want us to publish very fine resolution maps, then we're going to say, okay, we shouldn't do that if we not apply differential privacy.
No more questions? In that case, thank you very much, guys.
And thank you, Jack, for organizing such a great event and for helping us with the code last year and the organization of the UN Hackathon last year. It was great.
Pleasure.